Hello, I'm Mardanli. Today I will try to explain the third question from the second SDF. I hope it will be interesting for you. Okay, let's start. First of all, we read the question. Okay, H2 is produced in a steam methane reformer that is SMR at high temperature above 750 Celsius. That is methane plus steam or steam reforming is generally also we say that how 95% of the world's hydrogen actually made by reaction CH4 plus water, or also we say that for CH4 methane natural gas also we say that this. Okay, go on. Steam to methane ratio is 5. That is, we have in the left this, that is methane and water. Water per methane equal to 5. We easily find this formula. First of all, we must know mole of or kilomole per hour of water or methane. Doesn't matter. Okay. Then defeat to the reactor as it contains 10 mole percentage of N2. That is, we write here methane and 2 water, and the following reactions are taking place in the SMR. Consider 100 kilomole per hour flash rate. That is, methane is equal to 100 kilomole per hour. Okay, and then 90% conversion. Okay, we write 90 conversion, 90%. And as you know, in the products, we have CO2, N2, H2, H2O, that's water. Okay, that's all. We write. We don't write methane because we know methane uses the CO and CO2. Okay, then we read equation. Write down the chemical equations and equalize them. We write here this chemical equation, and if we equalize them, first of all we write name, that is, we say the first reaction, third reaction, sorry. We have both of them one atoms carbon, also the same oxygen, but hydrogen is left. That is, in the left we have six atoms, but in the right two. That's why we write here 3. Also here, carbon the same, but oxygen in the here 2. That's why we write here 2. This is equal to 8. That's why we write here 4. Okay, we write a question. And then B. Calculate the composition mole of each component of the fetus SMR. Okay, easy. Why easily? Okay. We have in the feed, on the feed to SMR, CH4, that's methane, water, and N2. We know methane is equal to 100 micromole per hour, and water is equal to X per kilomole of methane, that is 100 is equal to 5, because we say that here steam to methane ratio is 5 and N2 is equal to 10 mole percentage of N2. Okay, we find easily X is equal to 5 multiply 100 is equal to 500 gram per hour, and for finding N2 X per X plus 600 is equal to 1 per 10, and here we find X is equal to 66.7. we find also 67. Then we find mole percentage of each component. We know this is equal to 10, and if you find for methane we must note first of all the total of composition, that is 500, the total 500 plus 100 plus 67 is equal to 667 gram per hour. Okay, we write here 667 is equal to 100 percentage. Mole is equal to X. We find easily X is equal to 15 per percentage mole, and we find H2 or that's water easily. X is equal to 100 percentage minus 10 plus 15 is equal to 75 percentage. Okay, then another question. The selectivity of CO2 is 1 micromole per hour, and conversion of methane is 90%. That is, first of all, we know CO2 is equal to we write. Also, okay, we did say question. Calculate completed and non-completed methane and fill the table. We know CH4 converted and unconverted. Okay, converted and unconverted. Converted 90. Conversion of methane is 90. We know, and we easily write 100 multiply 0.9 is equal to 90 kmol per hour easily. Then we find use two ways. That's 100 minus 90 is equal to 10, or 100 multiply 0.1 is equal to 10 kmol per hour. I hope you understand this. Then D, calculate the total amount CO and CO2 and fill the table. We have here table right in the last. First of all, we calculation these equations, these reactions. Okay. Calculate the total amount of CO and CO2. We write again chemical formula. Methane plus water for the both of them is equal to, okay, we write here CO2 is equal to 10 1. That's why we easily write here 10 and this one. If we write here 10, also if we have if we find equilibrium, one more carbon, yeah, so we write here one more. Okay, one more 10 more oxygen is equal to 10, and yeah, hydrogen is equal to 30. For the second reaction, it's the same. That's right. Yeah. 10. Yeah. 4. Okay. Then total amount and fill the table. Okay. Write generally for the reaction 1 and 2. We write methane water CO2 and hydrogen. First of all, we find for first reaction, we write generally we use total of converted methane is equal to (90 kmol per hour). Easily we find, we write 90 divided by 10 plus 1, because we use generally 11 mole of this is equal to 80.2. And if we find for methane, we write 10 multiplied 82, because we use for first reaction 10 mole, and we write here 82 for the what is the same. Also CO is the same, because also we use the 10 mole of this, but for the first reaction we don't use CO2. That's why we mustn't use. H2 is equal to 30 multiplied this, and we write here 246. Then if we find for the second reaction, we write here easily we write here 8, because we know this sum of the 90, and we know for the first reaction is equal to 82, and we find easily for the reaction 2. And for the water we write 2 multiply it. So is going to use the second reaction, and here both of them is equal to 90. That's why we write here 8, and 4 multiply this is equal to 32. Okay, calculate then question. Calculate the reacted steam and exit steam and fill the table. Okay, easy. First of all, we know we use reaction. First of all, we know we have 500 kilomole per hour, and we use for the reaction, that is for reacted, these both of them, that is plus this is equal to water, water. Okay, now is equal to this plus 16 is equal to 98, and we like easily find exist. That is we don't use in the for reaction, and we write here 500 minus 98 is equal to 402 kilomole per hour. Okay, I think we find all of them, and then calculate the produced. Oh, sorry, we have another question. Calculate the produced H2 and fill the table. H2 is equal to this sum of the equation, that is this plus this is equal to 278 gram mole per hour. Okay. Now we fill the table. For methane, we know this is equal to 100 mole. So we find water 500. In the feed we don't use CO2 and hydrogen, that's why we don't use. We find easily N2 is equal to, I think, 67, and we find the total is equal to 667. And then we know methane is converted this. Water is equal to, as you know, reacted, we find reacted. CO is equal to 82, CO2 is equal to 8, H2 is equal to this, and 2 is the same, and we find easily some of them. Plus okay, again we write this, the sum of is equal to plus and plus. Find easily this equation is 16, and okay, the total of this. As you know, methane unconverted 10. That's why we find in the odd is equal to 10. Okay. Thanks to all. I think it was good, and thank you very much. Thank you.